Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in exercise 12.1 8 sum. Okay, so here the question is solve the given linear programming problem using graphically, and here we need to show that the minimum of z occurs at more than 2 points. Okay, so whatever it is, well, let's solve the solution and we'll see. Okay, now minimize the given question, minimize and maximize z equal to x plus 2y is given, and we can see 1 2 3 4 5, totally 5 constraints we have. So using the given information, we need to maximize and minimize the given z value. Okay, so first I'll tell the process, then we can move with the solution part. So what actually we need to do is using the given inequalities. Okay, 1 2 3 4 and 5, totally 5 inequalities we have, right? Using the 5 inequalities, we have to identify the common solution space in the graph. Okay, for all the 5 common solution space, we have to identify which is feasible region. Okay, so first we need to identify the common solution space, that is feasible region. Now after that, after finding the feasible region, then you can see whether it is bounded or unbounded. Okay, so what is bounded means the feasible region, you will get it as a closed figure, like a polynomial you can able to get. Okay, so that is bounded, and in case if you get it as a open figure, then it is unbounded. Okay, if it is bounded, that means you will get it like a polynomial shape, right? So you need to identify the corner points of it. Okay, after this step you have to identify the corner points, then all the corner points one by one you have to substitute in z. Okay, after substituting in the z, you will get the some results, right? So in those results, the largest value, okay, the bigger value is the maximum of the z. Okay, and the least one will be the minimum value of the z. So 100% sure we can confirm it. Okay, in case if it is unbounded, same process, corner point you have to identify. After identifying the corner points, substitute in the given z. Okay, you will get the some results, right? The least one will be minimum. Same, whatever we are doing for the bounded, same way, minimum, and the largest one will be the maximum. But since it's a unbounded, whatever result you will get, it's a 50-50 chances. Okay, it may or may not be the minimum. Whatever value you will get, that may or may not be the minimum, and whatever value you will get for the largest one, it may or may not be the maximum. To confirm that, what you have to do is, with the help of the minimum value, okay, you have to form a new inequality with the z. Okay, form a new inequality. Then that new inequality solution space you have to identify in the graph. That solution space of the new inequality and feasible region should not have any common point. Okay, in case if there is no common point for the new inequality and for feasible region, then whatever value you will get for minimum, no, that is the 100% for sure now. Okay, same way, with the help to confirm this maximum value, what we need to do is, using the given inequality, that z, sorry, using the z, you have to form a new inequality. Okay, then solution space you have to identify. If there is no common solution space between the feasible region and for the new inequality, then whatever value we are getting, no, that is the maximum, we can 100% we can confirm. Okay, so this is the process. Now let's get start with the solution part now for the given question. Okay, first to identify the common solution space, what we need to do is, for the given inequalities, you have to convert them as a equation. Okay, so what is the first inequality? X plus 2y greater than or equal to 100. So I'm going to convert this as a equation, x plus 2y equal to 100. Now I'm going to draw the line of x plus 2y equal to 100 for this line. So for that we need minimum 2 points. Okay, so minimum 2 points are required. If x equal to 0, then corresponding y value, if x takes a 0, then 0 plus 2y equal to 100, then 2y equal to 100, 2 1 times, 2 50 times, then y takes the value 50. Okay, same way, if y takes the value 0, no, x plus 2 times of 0 equal to 100, then what is the x value that we get? 100. So if y takes the 0, then x value will be 100. Okay, got it? Now we need to plot these points in the graph. Okay, 20, 20, I will take each unit. 20, 40, 60, 80, 100, 120, 140, 160, 180, and then 200. Okay, maximum this is enough, I feel. Okay, now it's the same distance here also. Each unit has a 20, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay. Okay, now what is the first point that we got? 0 comma 50. Now 0 comma 50, where do we have? Since x value 0, we will have only in the y-axis. So 0 comma 50. So it's between 40 and 60. The center point, this will be 50. So 0 comma 50 is this particular coordinate point. 0 comma 50. And what is the next point that we have? 100 comma 0. 100 comma 0 we have here. So this point is 100 comma 0. Now on connecting these 2 points, no, we'll get the line of, yes, and connecting these two, this is the line of x plus 2y equal to 100. Okay, now after drawing this line, no, the graph is dividing into two portions. One is above. This is the first part. Okay, one is this one. Second one is this. So we don't know which side we have a solution space for the given inequality. To identify that, randomly take any value from this side or this side. Anywhere it's fine. Let me take 0 comma 0. Okay, least value. Substitute in the first inequality. So 0 comma 0. Substitute in the first inequality in place of x as a 0. In place of y also 0. Then what is the result? 0. Is it 0? What is the inequality here? 0 less than or equal to 100. Is this true? Is this true? No, it is not true. Then the solution for the first inequality, we don't have this side. This side we don't have. Okay. The other side, that is upper side only, we have a solution. To confirm it, take any value 120 comma 20, any value which lies this side. No, you can take it and substitute. Surely it will satisfy the inequality. So what we can say now from this? From this we can conclude, for the first inequality we have a solution this side above the red line, including the red line. Actually they say it is, see, the given inequal greater than or equal to, so including the points in the red line, and this side we have a solution for this. Similarly, we need to identify for the second inequality. Okay, so now what is the second inequality that we have? 2x minus y less than or equal to 0. So to identify this particular line, no, what we have to do? We have to convert the given inequality as a line now. Okay, to identify the solution. Now let 2x minus y equal to 0. To draw the line of 2x minus y equal to 0 in a graph, minimum 2 points are required for us. If x equal to 0, then y also, if x is 0, y also is 0. 2 times of 0 minus 0, which is 0, no. Okay, but with the, is it 1 point is enough to draw the 2x minus y equal to 0? Means no. To draw the line, minimum 2 points are required. So one more point, I'll take some other value. X, y as a 120 I will take. Okay, y as a 120, any value. Okay, any value is fine. If y as a 120, if we take 2x minus 120 equal to 0, then 2x equal to what? 120. Then 2 ones are 260 times. So x equal to 60. So if x value is 60, then y value will be 120. So x equal to 60, y is 120. So this here it lies. So this point is what? 60 comma 120. And what is the first coordinate point that we got? 0 comma 0. So here we have 0 comma 0. Now we need to connect both the points now. Little more tilting. Sorry. I'm unable to cross both. Kindly excuse. Yes. So this particular yellow line is the line of which part? 2x minus y equal to 0. Okay, so this is the line of 2x minus y equal to 0. Using a scale you can extend it further. Okay, now this after drawing this yellow line, that is 2x minus y equal to 0 line, you can see that graph is dividing into two portions. Okay, other one is right side and left side. Okay, this side and this side we have. Now we need to identify where solution space we have for the given inequality. For that, randomly take any value. So shall we take 20 comma 20 this side? Okay, so 20 comma 20 where we will have here no. So this side I am going to check whether solution space is there or not, there or not. So 20 comma 20, if I substitute in the second inequality, 2 times of 20 minus 20. So what is the answer? 40 minus 20, which is 20. Is that 20 less than or equal to 0? Obviously not. So that means we have the solution the other side. This side if you don't have means then obviously we have solution this side. Okay. So we have a solution for the second inequality this side. You can see the red line and yellow line has a common solution space. Furthermore, we need to filter for the other inequalities. You'll see as of now double shaded. Now further third inequality. So first we need to identify the solution space. What we have to do? First we need to convert the given inequality as a equation. So let 2x plus y equal to 200. Okay. After that we need 2 points to draw the line of it. Okay, if x equal to 0, so 2 times of 0 plus y equal to 200. Now y equal to what? 200. If x equal to 0, y takes the 200. If y equal to 0, then 2x plus 0 equal to 200. Then 2x equal to 200. 2 1 times 200 times. So if y takes a 0, the x is 100. Now these 2 points we have to plot it in a graph. So first one is 0 comma 200. 0 comma 200 where we have here. Okay, so this point is what? 0 comma 200 point, and the other one 100 comma 0. So this point is 100 comma 0. Okay, now let's connect both the blue points now. Okay, now this particular line is 2x plus y equal to 200. Okay, this line is what? 2x plus y equal to 200 line. Now after drawing this blue line, we can see the graph is dividing into same right side and left side. We have to identify which side we have a solution. Okay, so let me substitute 0 comma 0. First let me check it whether we have this side or not. 0 comma 0 if we substitute in the third inequality. Okay, so 2 times of 0 plus 0, which is 0. Yeah, 0 is less than or equal to 200, right? Condition is getting satisfied. Then which side we have a solution? For the third inequality, we have a solution this side. Okay, this side we have. Now if you notice, okay, actually for the red line, if you extend further, no. Okay, if we extend this further, we will have a solution till here, I think. Yeah, till here. So now triple shaded portion where you are seeing starts from here. Yeah, only in the first quadrant, because the last two inequality says x comma y greater than or equal to 0, means what is that? x and y greater than or equal to 0 means only first quadrant. Okay, so if you convert the like other inequalities, if you convert x equal to 0, x equal to 0 means y axis. Okay, x greater than or equal to 0 means where we will have x greater than or equal to 0 means the solution space for x greater than or equal to 0 is first quadrant and fourth quadrant. Okay, for this first quadrant and fourth quadrant. Got it? Now same way, what is the second inequality? Y greater than or equal to 0. So converting it as a equation, y equal to 0. Y equal to 0 is x-axis, right? Basically it's a x-axis. Now y greater than or equal to 0. What is the meaning of this y greater than or equal to 0? Above the x-axis. That means first quadrant, second quadrant is the solution for this. Okay, now what is the common solution? Both inequalities shares x greater than or equal to 0, y greater than or equal to 0. Both shares only the first quadrant, right? So for our remaining all the three inequalities also in the first quadrant, wherever the common solution for all the three we have, that is the feasible region. So you can notice that. I'll just highlight it. So starting from here, yeah, starting from here. Okay, corner points alone, just I'll say. Here if you notice there is no red line, no. So till this all red, yellow, blue is there overlapping. Then here, here. Now all white line, white dots alone I'll connect it. Okay, we identified solution is there for the given set. That too feasible. That is solution, common solution we identified, no. So if common solution is there, what we say? Feasible region is there. So if feasible region is there, then what is that? Bounded or unbounded, we need to check. Since it's a closed figure, no, the feasible region is what? The green shade. This I'm shading right now, no, this is the feasible region for all the four inequalities. So since feasible region is there, and also you can notice that it is bounded. Okay, it is bounded. We need to identify the corner points now. So what is this particular point? 0 comma 50, and this point is 20 comma 40. I'll write the same. So this point is 0 comma 50. I'll name this as a. Okay, this point is B, that is 20 comma 40. You can see, so 20 comma 40. And next point is, if we don't know means we can solve. So this particular point is what? Yellow line and the blue line is meeting, right? So on solving with the help of the elimination method, we can able to track this coordinate point. Okay, now this point is what? This point is 200. Yeah, 0 comma 200. Okay, 0 comma 200, and this point we need to identify, and then B point. Okay, okay, and solving this we are getting like a 50 comma 100. Okay, this point is 50 comma 100. See in the graph, 10 points if we can able to take accurately, we can able to track this point. But in case if you have any doubt, just see that point. This particular point is a line joining of the yellow line and blue line. Solve them roughly using the elimination method. You can able to get the a common point, that is 50 comma 100 we can get. Now this one is what? 20 comma 40, and this one is 0 comma 200. So totally four corner points we identified. So first let's write. So the here feasible region exists. Feasible region exists for the given inequalities. So that means what? Solution is available for the Z. Okay, and it is bounded. So these are the keywords: feasible region, bounded. Do mention it. So it is bounded, and corner points are what are the corner points that we have? We named this as a no, 0 comma 50, and B is 20 comma 40, and the next point 50 comma 100, and the next point 0 comma 200. Okay, now all these corner points, now we need to substitute in the Z. Let's have a tabular column. Corner points and the given Z. So what is the given Z here in the given question? X plus 2y. X plus 2y. So first corner point 0 comma 50, the following 20 comma 40, 50 comma 100, and next one 0 comma 200. Okay, now substituting in place of x as a 0, in place of y as a 50. So what is the value we are getting? 100. So here it's 100. Next, x as a 20, 2 times of y as a 40. So 20 plus 40 into 2 is 80. So again we are getting 100. Next 50 and 100. So x as a 50 plus 2 times of 100. So 50 plus 2 into 100 is 200, which is 250. So we are getting the next one as a 250. Now substituting the last corner point, x as a 0, y as a 200. So 2 into 200, which is 400. Okay, 400. Now compare the results. Out of all this, which is the biggest value, largest value, which is 400? No. Then this is the maximum value of the Z. Out of this, what is the least number? 100. But 100 we have twice. So minimum is 100. And whenever results occur twice, what you have to do is whether 0 comma 50, 20 comma 40, whether it's forming a line segment, you see in a corner point. Okay, in a feasible region, whether it's sharing line segment or not, you have to check 0 comma 50 and 20 comma 40. So 0 comma 50, 20 comma 40. Yes, you can see it's actually sharing the line. So this point, it's actually sharing the line segment, right? Then not only 0 comma 50, 20 comma 40, all the points in the line segment, that is AB, in the line segment AB, gives you the maximum. Okay, so not only at 2 points, we'll write the same now. Okay, therefore maximum value of Z is 400 at only one point, 0 comma 200. But minimum value of the Z, minimum, okay, minimum value of Z is 100 at every point, because 0 comma 50, 20 comma 40, if you notice in the feasible region, it's sharing one of the side, no, it's a line segment. So every point, at every point in AB. Okay, not only at these two. Understand, 0 comma 50, 20, not only at these 2 points, at every point between the A point and B point. Okay, not only between, including that A point, B point, then complete in line segment gives you the minimum value. Okay, so that's all the solution. And every thank you children, thank you.